we are now going to talk about how to recognize whether a given relation is a function or not. And again, this comes back to the primary definition of a function is it's a relation where each input has only one output. So if it has more than one output, it can't possibly be a function. And so we're going to start by looking at the sets R and S, which have points, input-output pairs. And so we look at each of these points, and we look at the inputs, and we say -1 gives 2, 1 gives 3, 5 gives 2, and -1 gives -3. And I have matching inputs with non-matching outputs. This is not a function. If I have a repeat on the inputs, it's not a function. Notice it's okay to have a repeat on the outputs. That doesn't bother me. It's just the inputs that can't be repeated. Well, when we look at our second one, -2, 0, 2, and -1, none of those are repeated. That's all of them. So as long as this is all that's given to us, this is, in fact, a function. So all we're doing is looking at the x's and trying to find repeats or not. Well, sometimes we have our correspondence maps. So here's our correspondence map again, and what we're looking for is we look at each point, we see how many places does this go to. And notice this goes to 2 different places. So my one input has 2 outputs, so this is not a function because it has 2 arrows coming from the same input. On the other hand, this -2, -1, 0, and 2, each input has only 1 arrow coming from it, so this is a function. And if you notice carefully, this was our R from before and this was our S, just expressed differently as a correspondence diagram or a map instead of as a list of points. Well, here's a table form of the same thing, and again, we're looking for the same thing. We're looking for repeats with different Y's, so this is not a function. And again, notice it's the same R that we looked at before. And our S, -2, -1, 0, and 2, no repeats, so this, in fact, is a function. What if we were to plot these points? Well, here we're just going to look at our single input. This input right here at -1 has 1, 2 outputs, so again, this is not a function. In our other case, draw through, draw through, draw through, draw through. Notice each one only hits once, so this is a function. Notice I didn't even bother looking at these two because this one line, this one input of -1 has 2. As soon as you find a reason to stop, stop. You're done. That's all you need to look at. Now the tricky part. What about when I have equations? And the idea here is we want to solve for y. Try and get that y by itself and see what you get. So we take minus the 6x squared from both sides. We get -3y equals 12 minus 6x squared. Divide by a -3. That gives me y equals a -4 plus 2x squared, or y equals 2x squared minus 4. I got the y all by itself, and my x doesn't have any plus or minuses or anything. This turns out to be a function, because when I get the y by itself, the x's take care of themselves. Because if I square a number, I only get one number. If I cube a number, I only get one number. It's what happens to my output that matters, not my input here. So as we're looking at this just a little bit more, let's look at this other one. Y squared minus x squared equals 4. And again, we want to get the y squared by itself, so we add x squared to both sides. So y squared equals x squared plus 4. And we take the square root. And remember, when we take the square root of a variable, we need to use the plus or minus. So y equals plus or minus the square root of x squared plus 4. And right here, this says that for a given x, when I square it, add 4 to it, and then take the square root of it, I'll get a positive version of that and a negative version of that. That's 2 answers. That doesn't work. We're not happy with that at all. So we come back and we say, this is not a function. So as a general rule, I can do anything I want to the x, but I have to be careful what I do to my y. Even powers in particular kill it. Or if the problem starts with plus or minus signs, that kills it too. And this makes it very, very, very simple to determine whether an equation is a function or not.